Assalamualaikum and hi, my name is Nur Saleha binti An Hazubir. Today, my partner Ahmad Fiti bin Ibrahim and I, Nur Saleha binti An Hazubir, would like to present to you on our final year project entitled Automatic Pie Garden. According to Gehenna, Fried and Meridia, there is much attention to inflate household food security and nutrition by using home garden as an approach. This project is developed as a smart garden as it is ideal for people with a busy lifestyle to commit. Automatic Pie Garden is a system that involves a web-based application that provides a chance for people to have their own remotely controlled garden in their houses without worrying about watering, lighting and fertilizing their indoor garden. Automatic Pie Garden will be developed using Raspberry Pi 3B Plus as the hardware and a server created in order to connect the Raspberry Pi with users' devices. Automatic Pie Garden is provided with a camera for the user to monitor the conditions of their garden. Next is the problem statement. Users have difficulty in managing their garden when they are busy or away from home. They tend to forget to water their garden when they have a lot of work to do. They also cannot take care of their garden when they are away from home. The garden will die due to not having enough water or sunlight as they plant inside their house. Furthermore, insects will be one of the destroyers of the garden. The insects may have destroyed the garden that is left unprotected. In some cases, people are forgetting to fertilize their garden at some time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fiti bin Ibrahim. We discuss about objective of our project. The first objective of our project are providing a system for users to plant in your garden without having trouble to manage it. The second objective are to encourage people to stay healthy and lessen the effect of global warming. The last objective are to allow people to manage their garden remotely. Next, we will compare our project with 3 other products currently in the market, which are Smart Garden 9, AeroGarden and Bosker Sky Planter. All product has functionality in watering plant, but does not have any fertilizing functionality. Smart Garden 9 and AeroGarden has light, customized day and moisture sensor functionality. Bosker Sky Planter has limited functionality that only helps in watering the plant and does not have other functionality. All product does not have camera and provide history of using functionality. Camera is important to make sure that the condition of the plant. The system development life cycle for our automated pie garden is an iterative model. Iterative model helps this project to improve the features and the function from time to time. The project needs several activities like planning, gathering requirements, analyze and design, implementation, testing, evaluation and deployment. The life cycle will go on until the all requirement has been implemented. The reason why this project uses an alternative model because we have several requirements that need to undergo all the processes mentioned in order to make or identify the requirement without hassle or affecting the entire process. Iterative model is very easy to adapt with additional requirements and change to suit the need of the project itself and also not have a big effect to the cost of the project. It also suitable with this project due its ability to adapt change with a minimum time frame. The last one are the framework and language that we use in order to make sure the system works. Python and HTML language are used by the team as the main programming language for the system. The system uses Flash framework for interface development. Hardware that we use Raspberry Pi 3B Plus, water sensor, soil moisture sensor, relay board, grow light, and Android smartphone to access web application for automated pie garden.
Here are the prototypes of our system. In the development of Automatic Pie Garden, a rough idea or the designs of the system user interface has been made. The system is designed with the purpose of having users of different ages ranges to be able to use it. Hence, the design is to be made with ease to understand right away without having to watch tutorials on ways to use it. The concepts of the designs is represent this garden concept where it has an element of green. The system does not use heavy element of graphic and wording as it will only distract users from the main functionality of the system. Now we are going to show you our project demonstration. First of all, we have to run our code that we have created in the Raspberry Pi and they can with our Flask framework. So here is our website. First, main page will be showing the login page where the user needs to key in the user ID that is already been given when the user has the product. So here you click here and then you click your ID and then your password. And then you click the login button. Upon clicking the login button, it will direct us to the home page where it will show us the designs of the automated plant garden. We have two pumps and there is one for water and then another one is for the liquid fertilizers. And there is also a LED grow light to replace the sunlight. Okay, here is a site navigation bar where it shows you the status, reports and settings, also the logout button. Upon clicking the status, it will show you the status of your plants. You can just go to the reports page. It will direct you to the report page where it will show you on the last one on the histories of the activities. You can also view your full report. Here is the full report.
Next, we proceed to our main functionality at the page setting. There are four main functionality in setting which are watering, lighting, fertilize and camera. First, we go to watering page. In watering page, user can choose two automation which are timer and moisture automation. When users switch on the moisture automation, watering process will check the moisture sensor before it decides water the plant or not. For timer automation, it will water according to the time and will ignore the moisture sensor. Here, user can choose to water their plant once per day, twice per day, thrice per day. The time to water is fixed. For example, user choose twice per day. The system will water fixed at 9 AM and 9 PM. By clicking this button, the system will water the plant immediately. Next, we proceed to lighting page. For the light, we will only provide a timer automation. The grow light will on at specific time that has been set in the system. User can choose to light their plant once per day, twice per day, and thrice a day. Last for the light page is manual lighting. When user click this button, the system will switch on the grow light immediately. After that, we proceed to fertilizing page. Fertilizing page is quite similar with lighting page. It has timer automation but will only available once per week, twice per week, thrice per week. Last for fertilizing page is manual fertilizing. When user click this button, the system will fertilize the plant immediately. Reminder, user can only use liquid fertilizer for this functionality. Lastly, we proceed to camera page. Functionality of camera are limited to taking photo only. When user click this button, Pi camera will take photo immediately and user need to refresh the page to view the photo. When user click this button, it will automatically log out from the system and redirect the user to login page. That's all from us. Thank you.